Let's break free from the chains of popular physics by exploring a logical contradiction within the theory of special relativity. Remember, it takes only a single contradiction to disprove a theory, and soon you'll have evidence to share with your friends that relativity is broken. You've got Quil and Bob, and this is a thought experiment we designed called the Disc Shattering Paradox. The Disc Shattering Paradox can be described in 3 steps. First, spaceships. Our setup begins with Pixel the physics cat as our observer stationed on Earth. He notices that Quil and Bob have built some pretty fantastic spaceships. Bob has erected a ship that resembles a simple rod of length L and a diameter of d. Quil is piloting a ship of identical mass that resembles a hollow tube open on one end and closed on the other. The internal chamber has a depth of L and a diameter of 2d. Bob's spaceship is designed to dock within Quil's such that a docking mechanism will trigger when the front edge of the rod is driven into the tube and makes contact with the far internal wall. And since the lengths are designed precisely, the rear edge of the rod will be aligned perfectly flush with the open cylinder edge when docked. Not only do these spaceships dock together, they are devised to do so at very fast velocities. Fuel is expensive, so the docking mechanism is designed to absorb the kinetic energy of any collision and store it as potential energy in a battery system within their ships. This configuration allows for perfectly inelastic collisions, which is just a fancy way of saying that once they collide, they will stick together and act as a single unit. There is an added elegance in the design such that if the 2 ships collide with one another at equal and opposite velocities, they will smack together and come to a dead stop. One final touch. Bob adds a massless easy breakaway disc to the rear of his spaceship. It is made of a sturdy material capable of withstanding high speeds, and, this is key, will remain intact so long as the rear edge of Bob's ship never breaks the plane of the open cylinder edge of Quil's ship. However, should the rear of Bob's ship ever enter into the interior chamber of Quil's ship, the easy breakaway disc will shatter effortlessly. Done. Our spaceships are designed. Remember, this is a thought experiment, so the materials and measurements used are perfectly precise and act exactly as expected. Step 2. Experiments. Quil and Bob navigate their spaceships far from Earth to avoid any outside fluctuations or influences. They position their spaceships some distance away from each other and accelerate to constant velocities. Their velocities are equal, opposite, near the speed of light, and perfectly aligned for docking. The nature of their acceleration is unimportant, as the timescales within this experiment are unimportant. They will travel at these constant velocities until they dock together with perfect inelasticity and come to a dead stop. First, let's imagine the experiment from the perspective of Pixel, the physics cat. As a stationary observer watching spaceships that are moving at velocities near the speed of light, Pixel immediately notices the length contraction. Pixel is not surprised. No, Pixel knows that length contraction is a phenomenon that arises from special relativity, where a stationary observer will measure the length of an object moving at near the speed of light to be shorter than they would measure the same object to be if it were at rest. This contraction happens only in the linear direction of travel. Also, the object undergoes more length contraction the faster it is moving compared to a stationary observer. And it is important to understand that length contraction is not an optical illusion or an error in measurement. It is a true physical manifestation. The length actually becomes shorter in physical reality. Pixel observes both Quil's and Bob's fast-moving ships are shorter in length than their stationary sizes. Let's watch what happens along with Pixel the physics cat. Pixel notes that as the ships dock, they come to a dead stop and expand back to their stationary lengths. Aside from that, nothing else very exciting happens. But what does Bob experience? Let's go back and imagine the same experiment from Bob's perspective. To do that, you first need to understand switching reference frames. Switching reference frames is easy and important. Imagine watching an airplane flying by clouds on a calm day. From an outside observer's reference frame, the plane is moving and the clouds are stationary. However, you can also imagine this same event from the reference frame of a passenger on the plane. From their perspective, the plane is stationary, and it is the clouds that are moving. Remember, during the experiment, Pixel observed Bob's ship contracting, so you might reason in those moments that Bob would observe the expansion of Pixel and the Earth. But this is not the case. Special relativity has a core feature called reciprocity. Reciprocity requires that the laws of physics behave identically from any observer's frame of reference. In other words, each of our 3 observers in our experiment can claim that they are the stationary observer and it is everyone else that is moving. With everyone else moving near light speed, they must be the ones that undergo length contraction. Remember, these are not illusions. These outcomes are equally real in the physical world. Let's rewind as Bob has claimed his relativistic right of becoming the stationary frame. And since his spaceship is at rest, it retains its stationary size. Bob sees the planet Earth moving out in the distance at a velocity near the speed of light, and further observes that the entire planet has length contraction in its direction of travel. Much more alarmingly, he observes Quil's ship approaching his at an even more extraordinary speed that is even closer to the speed of light. As such, the contraction of Quil's ship is even more pronounced than the contraction of Earth. Fortunately, their ships were designed to dock at these speeds. As they are docking, Bob recognizes that his rod is substantially longer than her cylinder, and that the rear end of his ship is far from the edge of Quil's. Upon docking, Quil's ship and the planet Earth come to a stop and their lengths expand back to their stationary sizes. In other words, Quil's cylindrical ship expands to envelop the entire length of Bob's ship. The cylindrical edge ends perfectly flush with Bob's rod. The disc remains intact. That was extravagant. But what does Quil experience? Let's rewind one last time and imagine the same experiment from Quil's reference frame. Quil insists that she is the stationary frame, and so this time her spaceship will retain its stationary size. Quil sees Pixel on Earth moving near the speed of light out in the distance. Both Pixel and the planet have length contraction in their direction of travel. And there's Bob moving even faster on his ship and experiencing even greater length contraction. Wait, but Quil recognizes that Bob's ship is far too small as it approaches. The rear end of Bob's rod enters the interior chamber of Quil's ship, shattering the disc. Impact occurs a moment later. Bob's ship and the planet Earth expand to their stationary sizes as they come to a dead stop. Bob's rod once again fits perfectly flush with Quil's tube. However, Quil laments the shattering of the disc. Step 3. Reality check. Bob invites Quil and Pixel to celebrate. Phew, all of this length contraction is making me thirsty. I think I'll order a... Wait, what's wrong, Quil? What's wrong? Our experiment was a complete disaster. The disc is completely shattered. But that's not how I remember it. Let's take a vote. Did the disc remain intact? From Bob's and Pixel's perspectives, the disc remains intact. However, from Quil's perspective, the disc shattered. Wait, reality is not a democracy. Special relativity has created 2 contradictory physical outcomes from a single event. It is logically impossible for the disc to be both intact and shattered after the experiment, assuming Quil Bob, and Pixel all still exist within the same physical reality. How does one reconcile the paradox? That's easy, by recognizing it was special relativity that shattered. Remember, it takes only a single internal logical contradiction to discredit a theory. Let us know in the comments how you would reconcile this paradox. What's that, Pixel? Infinite number of paradoxes use say, "Explain yourself."